Good afternoon and welcome to the 28th annual exhibit of hydrogen and fuel cells. Hydrogen and fuel cells. Hydrogen and fuel cells. We talk about this, but we never mention where is the hydrogen coming from. We know that it's been steam reforming for the longest time. We say to our own shame, that is, we're using hydrocarbons to create hydrogen. To this day, some people will claim that only 1% of the hydrogen used nationally, industrially, it's an industrial gas, is created through renewable energy and electrolysis. Someone may correct me on that proposition, but here's the problem. Here we are in Germany, and we know, not since the war, we've known for decades that we're going to have to replace fossil fuels. Some of the terms we've heard in the past are, when do we reach fossil fuel parity? Our jaws dropped in 2017 when we reported this. What does that mean? It means that all of a sudden, for a kilowatt hour, they used to talk about the price per kilogram. Don't do that anymore because no one knows what that means. Talk about the kilowatt hour. When we're competing with fossil fuels, it's no longer simply a proposition of cleaning up the environment. It's also affordability. There are applications that use hydrogen very effectively. There are all sorts of commercial prospects. But when you talk about electrolysis, you're talking about using renewable energy to create green hydrogen, and then you have to ask yourself, is this a viable way to supplant, to replace the fossil fuels that we are importing despite a war? This is a very, very important topic this year. It's all they talked about yesterday on the news when they showed images of the fair. They only visited this stand here, ladies and gentlemen, and all the politicians were talking about is hydrogen. They don't even add the green hydrogen. There may be an assumption there that it's green by nature when we know it's not. These people have come to occupy the largest number of square meters at this stand. That is, the electrolysis industry, when I started, it was, well, a scarce representative at this stand, this whole Hall 16. And now it occupies more space than any other field in the industry. So it's obviously a growth industry, but it is a fundamental industry. I would like to hear the presentations first of our 6 guests, and then we're going to discuss where this is going to lead. Is it actually viable to replace fossil fuels through renewable energy? What does that involve? Can they ramp up production of the electrolysis industry to the extent that it really provides the quantities we need in order to even deal with the electrical grid, which is only 15% of the energy consumed in Germany. The other 85%, of course, that's fossil fuels. It's going to be a very interesting conversation. First, the presentations. So first, our guests come on the stage individually and talk about what they do and their various applications. And then we're going to get into this debate. We're going to, of course, invite the audience to join in the discussion and see where this is leading. And for those who stay to the end, there's going to be wine and beer, so it's worth it. I would like to invite my first guest up on the stage, David Guro, who is Vice President of Product Management at Aqua Hydrex. David, you have the stage for your presentation.
Are available online? Or?
Good afternoon, everybody. Thanks for that nice introduction. I think this will be an exciting forum. You're going to hear from a new company or companies like myself, like Aqua Hydrex, and also some companies that have been around for a number of years in this business. So I'm the product manager. Do I advance or are you going to advance? Sorry? Thank you. All right. Now we're ready. All right, so I'm Dave Guro. I'm the product manager at Aqua Hydrex. It's a new company on the scene, as we'll go through. We're a new electrolysis company that's been fundamentally looking to redesign or reimagine an ideal platform for alkaline electrolysis. You know, we get asked a lot as we're walking around, are you a pump company or an alkaline company? And we say, well, what if you could have the best of both? What if you could have the current density and the efficiency of PEM, but do it in an alkaline, low-cost CapEx environment? So that's what we're striving to do with our system. So when we say clean sheet redesign, that's really what we're doing. We're looking to optimize the system for the lowest cost of green hydrogen for the industry. Not the lowest CapEx, not the lowest efficiency or the best efficiency, but both drive towards the lowest cost of hydrogen itself. Like I said, we're a new company. We're coming out of the lab phase. We built our process demonstration units, and we're doing the testing now. And we're getting ready now for the product launch over the next coming months. So very excited to be here. So when I mention a clean sheet redesign of electrolysis, like what does that mean? Well, it means a lot of things. But for us, fundamentally, we're looking at the cell level. And we're doing a redesign of the cell within the alkaline electrolyzer system. And the fundamental attribute of the redesign is confining the electrolyte within the cell. So we call it a confined KOH, or confined cell design system. By confining the KOH at the cell level, it means we're eliminating the large flowing KOH or alkaline electrolyte loop, okay, that all electrolyzer systems that are alkaline today have. So what that means is, I'll go down the list, each cell is ionically isolated one from another. So if the cells are ionically isolated, you don't have to worry about reverse currents on shutdown or for rapid changes in renewable input. So it also means that because our catalyst can withstand the shutdowns and the rapid turn up and turn down, we can use non-PGM catalysts. So we can use low non-noble metal catalysts that are low capex, but we get the PEM current densities and high efficiencies because we're electronically isolated, or ionically isolated between cells. Furthermore, within the cell design, we've put together a passive pressure control system, or pressure management system within the cell at the cell level. So what that means is as renewable inputs, the sun or the wind turns up or turns down very quickly, the electrolyzer can actually follow nearly instantaneously, like go from 0% output to 100%, back to 0%, much less than a second in time, okay? And in an alkaline system, that's fairly unusual. We don't need batteries, to hold charge on the system. So that means we can have an unconstrained ramp that can take advantage of the lowest cost power, which is that ungrabbed renewable power. Cell level cooling, that's another change within the electrolyzer system. We're doing cooling through the bipolar plate at the cell level. By doing that means we can push high current densities, remove heat from the cell at the point of generation, which leads to process intensification while keeping the high efficiencies. And finally, as you'll see, we've come up with a modular compact system, which simplifies the overall project cost for a project developer. So here's an engineering rendering of what our system will look like. The idea is to put together a compact shipping container-sized system. It's about 5.5 megawatts of electrical input, which gets the PEM kind of performance, like I said before, but in that alkaline, low-cost system. Because the system's highly responsive, we can directly tie it to renewables, right? You think about producing electricity. What's the biggest cost component in electrical production for anybody's system? It's power. So efficiency really matters. So we can get really high efficiency, but we can also use the lowest cost power, which is that intermittent renewable electricity. The system's designed for high volume manufacturing. The componentry we're choosing for the cell design means we can automate the manufacturing of the system, which will really drive down capital cost as we ramp up production. And we think importantly, we're generating both the hydrogen and the oxygen at 30 bar pressure. So for many of the industrial applications that are out there today, that means you don't need product compression for the hydrogen product, which is quite expensive. And if we look at there's no numbers on here, but if we look at how we project our initial costs as we launch next year, but as we look at our cost projections in the future years, we see pathways directly to achieving the various policy targets that you see in the States and in Europe that are quite public. We've assembled quite an experienced team that are pictured here. The one thing I wanted to mention is our heritage is actually from an investment group called True North Venture Partners. If you're familiar with First Solar, they're one of the big solar companies in the U.S. They still manufacture in the U.S. The chairman the First Solar is actually the chairman of our board as well. So we have some really good heritage, with the renewable industry through that. So then just in summary, where we're at, again, we're preparing for product launch. We're really proud of the technology that's been developed. We've demonstrated it at various scales, at the lab scale, at the process demonstration unit, and we're focused now on market entry. We're looking to enter the market where we're optimized for the lowest cost of hydrogen. Again, we're not looking for low capex or best efficiency or low O&M. We're looking for low all of it. We're trying to find the intersection that derives the lowest cost of hydrogen for the market. And so you have a chance, you have any questions, there's three of us, Steve, our CEO, Sam Morton is here as well. We're here looking forward to meeting and talking with anybody about the subject. So thank you very much. I'll leave this here.
Thanks, Dave. So, where's Kristian? There you go. So up next on the stage, I should do this where I'm visible, Kristian Kvist, who's Technical Product Manager of Nel Hydrogen Electrolyzer. Yeah, Kristian, you have the stage.
Thank you. Yeah, so my name is Kristian Kvist. I'm the Technical Product Manager at Nel Hydrogen Fueling. And today we are here placed in booth number 46, so feel free to come by. And let me see here. So Nel as a company, our vision is that we want to empower generation with clean energy forever. And we will do this by using hydrogen. So we want to deliver optimal solutions to produce, store, and distribute hydrogen from renewable energy. So we do not care if it's an electrolyzer or a PEM electrolyzer, alkaline electrolyzer. We have both. We don't care if it's for fertilizer, if it's for fueling stations, if it's for a steel plant. We want to produce, distribute, and store renewable hydrogen. And that's why we have both PEM and alkaline electrolyzers, and we're trying to give our customers the optimal solution. So in some cases that's in PEM, in some cases it's an alkaline, but it's very dependent on the project, where it's located, on the size, on the requirements in terms of flexibility and available power. If we look at our fueling side, there we have a fueling station, which is a modular system with a station module where we have our compression cooling technology, which functions like the heart or the brain of the complete system. Here we can distribute up to 1,200 kilogram hydrogen per day via a dispenser. This dispenser can be placed up to 50 meters away, so there's a quite large flexibility in terms of site design. Further, the dispenser is quite compact, so it fits in together with diesel or petrol station, so you can actually place your hydrogen dispenser next to conventional fuels, and for customers, they just go in and fuel the vehicle. Our fueling station manufacturing plant is located in Denmark. It's quite new. It's from 2017, and we're capable of producing up to 300 stations per year. And if we look at where we are in the world, our main focus has until now been Europe, US, and South Korea, which we see as some of the largest markets. So in Europe, we are placed in the majority of Europe, especially North and West Europe. And in US, we are on the West Coast, as well as in Canada and in Korea. In total, we have sold and installed more than 100 stations in the past years, and our fueling division is almost 20 years old, and our electrolyzer division is soon 100 years old. So we are quite experienced in the hydrogen world, and we are only playing with hydrogen. That's also why my last slide is thanks for the right dinosaurs. We'll take it from here.
So if you could pass the microphone on to who's next? Florent Baudu, who's Sales Director Industry at McPhy Energy. Welcome, Florent.
Hello, thank you very much. Ladies and gentlemen, good afternoon. I will have to bring you in this third ride in the elevators this afternoon. Hope you will enjoy. And I will tell you a story. The story I will tell you is a nice story, but it is a true story. It's a real one, which is important. Actually, I'm going to talk to you about the SEOC project, which is a real project, which is about the first multi-megawatt hydrogen power plant in the world, as you see here, which is to be installed in French Guiana in South America. This project will aim delivering power to 10,000 households in the vicinity of the whole plant. The whole plant comprises not only electrolyzer, but also PV farms, batteries, fuel cells. And what is also interesting is to notice that the whole project, which is financially closed today, which is under construction, aims to reach the competitivity against the diesel for this typical project. McPhy has been selected, I have to say, after a fierce competition, which was not easy, as the supplier of the electrolyzer for this unit. And I'm going to tell you a little bit more about the technology that we are implementing for this project. Actually, as you see here, the 16 megawatt electrolyzer, which we are constructing at the moment, will be completely installed in French Guiana, in tropical environment. It will be fed completely by the PV farm, which will be a first of its kind. It is based on our current technology, pressurized high current density alkaline electrolyzer. Actually, as said, it's under construction. The commissioning of the electrolyzer and the whole plant is set to be in 2024. You see here a bit more details about the installation, about the modules, 4 megawatt modules of the electrolyzers. We have 4 modules of 4 megawatt, fully outside. The stacks, as you see there, are inside containers. The separators between the electrolyte and the gaseous phase is fully outdoor with some rain shelters, as well as for the final purification of the whole unit. Of course, one of the constraints was to set the complete equipment to fit with the local environment, tropical conditions, which is also a challenge, of course. What is important to say, a part of the only supply of the electrolyzer, installation of the electrolyzer, it is that this electrolyzer is the stepping stone of the whole industrial scaling up of not only McPhy, but also an important part of the complete ecosystem. As you see here, today within McPhy, we have already more than 100 megawatt capacity. We have a plant in San Miniato in Italy, where the capacity was 100 megawatt in 2021. We are raising the capacity. At the end of this year, we will reach 300 megawatt capacity, which is the maximum physical capacity of the plant. On top of that, we are part of the IPCEI process, pre-notified, and by 2024, upon final confirmation, we will add to the 300 megawatt 1 gigawatt capacity with a gigafactory which will be installed in France. Last but not least, to notice as well, because this is usually a major concern of the people who are implementing such big projects, together with the pure capex and the delivery of the electrolyzer, we have an LTSA, a long-term service agreement, which is part of the package to ensure that the maintenance of the electrolyzer, even in remote places such as French Guiana, is ensured, and that the performances of the electrolyzer can be monitored and kept during the lifetime of the project itself. The ride is over. Hope you liked it. If you have questions after it, just please feel free. Thank you.
So, could you, I'm running out of hands here. That's the microphone for our next person up on stage. And I'd like to welcome on stage Saro Capozzoli, who's co-founder and director of H2 Energy. Is he in the room? Yes, he is. There you are. Okay, let me pass on the microphone. Welcome.
Hi, the presentation. Good afternoon. It's a pleasure to be here, and I will do a very short presentation because I think you have seen so many presentations today that I think you are more expert than me about hydrogen. I would like to introduce briefly my company. Yes. I think we have many things to say, but in 3 minutes, what I can say that we are electrolyzer producers. We have in our pipeline all 3 technologies: the alkaline, the PEM, also the AM technology. I can tell you our company is relatively new, but we have a team of experts and technicians that have more than 25 years experience in the sector. And what we did with my partners was to bring together expertise and people in order to have the best of Italian minds in Italy, because some of them they were outside Italy. We asked to come back, and we have done our best to start up these companies, and we are already able to produce not only in paper but in reality. In fact, our first PEM factory plant is on your back in that container, and so we are producing real projects. What things we have the full range of equipment. We have now a joint venture in place in India, where we are going to produce alkaline stacks and the plants between 3 to 5 megawatt each stacks. In Italy, in Europe, we are focusing with the PEM and as well with the AM. About AM, I want to tell you some news, something in advance. It is a technology that where we believe a lot. We are investing a lot of money. We already have invested millions in our lab and our research. And end of this year, we are going to produce the first megawatt single stack AM. And next year, we will be here. We will present to everybody this machine that will be ready to be launched at the megawatt scale. So we are not speaking about small size stacks, but we are going to bring AM to the megawatt scale. This is a brief introduction to our AM that is implemented in this period. And this is, we can see that this will be a game changer, because we simplify a lot the layout and the BOP of the plant. We have 1 pump instead of 3. We simplify the system, and this will be a game changer also for what concerns the capex, because we can beat all the other technologies with at least 40% cheaper compared to the other technologies. One thing is important that this will be not replacing a PEM, because PEM will be always in our pipeline, in our project. In fact, this year we are going to produce about between 5 to 6 megawatt. This is one of them. And next year we have a pipeline between 30 to 40 megawatt. In 2024, we will start our automated factory to assembly stacks. We are going to above 100 megawatt. So we have the target to start in Italy the first gigawatt factory, starting from here. Applications. We speak about application because we are discussing several projects. This is one of them, for example, where there are already hydrogen train already in place, already purchased. And our philosophy is to produce hydrogen where it is needed. This is our main target, because we listen to the discussion about everywhere in conferences, European scale, gigafactories of hydrogen production, but this will be possible only when the technology will be mature and we will have enough improvement in the storage and the transportation. So for this reason, we are focusing. We prefer to do a factory of 10 megawatt rather than a single factory, 10 megawatt rather than single factory of 100 megawatt. This is more reliable, realistic, and in fact we have a discussion in ports, airports, in logistics center, industrial unit. We have something interesting. In this moment we are discussing with steel factory, secondary steel makers, where we will introduce our machinery equipment in the production of steel, where there will be used hydrogen as a reduced element for the steel, and oxygen will be also used as a fluidification fluid in the steel, about 40 normal cubic meter per ton. But one application that this plant will be applied, it is the steam production for food processing. We have plenty of food processing factory in Europe, in Italy, where it is used a lot of big quantity of steam generation, and produced by methane. Now we are going. This plant will go to industrial unit where will be mixed. The hydrogen will mix with the methane in order to reduce the cost of the steam production. And in a short time, we are going to replace methane with hydrogen. So we are looking for application, local application, like in the steel, in the glass production, ceramic production. So we need to start from where we need to act at once to reduce the CO2 impact. Then, step by step, when the technology will be mature, we are going to produce the big factory to concentrate, but we need many investments also in the storage and in the pipeline, in the transportation. Until that moment, it will be very difficult to speak realistically about this kind of diffusion. We are located near Milano, near Cremona, and this is, we can hope, we are the first hub for hydrogen in Italy, and we are very happy to work together with our competitors to get the market together. Thank you very much.
So up next on stage, we have Jeremie Bertrand, who's Business Development Manager at Cummins. Jeremie, you have the stage.
All right, thank you very much. So, Cummins. Cummins is an American company, Fortune 500, present in 200 countries, and very famous all over the world for manufacturing diesel engines and power gensets for more than 100 years. So why I'm here today? Because Cummins, in 2018, began its path towards equipment for the environmental transition, creating a new business unit called New Power. New Power is commercializing products like batteries, powertrains for electric vehicles, fuel cells, and electrolyzers. With the acquisition of Hydrogenics in 2019, Cummins gained more than 50 years experience in the electrolysis business. And my main message here is that we are one of the few companies that has a product dedicated for each scale of projects today. We have small scale applications with our alkaline containerized turnkey solution for projects below 1 megawatt. Then for projects below 10 megawatt, we have PEM container, also turnkey at 30 bar. And for projects bigger than 20, around 20 megawatt, we can push with our indoor solution with 5 megawatts building block that are installed today. So all the products that I've just mentioned are today installed, commissioned, and operated since more than 1 year. For the projects to come, bigger than 1 megawatt, we are developing and finalizing the design of the big brother of the Hydrolyzer 1000, the Hydrolyzer 4000, which is a 20 to 25 megawatt building block. These two products, indoor solutions, allow customers to optimize their full application, optimizing the balance of plant meaning also balance of plant for the full application. We're working, for example, with KBR Technologies since 3 years to integrate our electrolyzers into their Haber-Bosch process to produce green ammonia and have an integrated solution for green ammonia production. We have products for any scale of project, we have also products for all geographies. And how are we serving all those geographies? We're scaling up today our manufacturing capacity in Belgium and in Canada, our historical sites, but also adding new capacity in China to reach a capacity of 2 gigawatts by 2023. Here I just wanted to show you why we choose PEM, or more than just efficiency and flexibility, why we choose PEM for large-scale applications. There are some hidden advantages that you can see here. First, you see here our PEM cell stack for 1.25 megawatt and 2.5 megawatt, and you see that we don't increase the footprint while doubling the capacity. This has first advantage, savings on land and on building. Buildings are smaller, but there's a hidden advantage. The capacity of that stack allows us, with our spatial Cummins design, to enclose all the ATEX areas in boxes, and this means that all the building around our electrolyzer is not ATEX. It's safer because operators do not work in an environmental in an ATEX area, and also the last advantage is that this enclosure allows us to stop one unit and put them for maintenance, and also continue to operate all the other units. This means that the availability of the plant is higher. Combined with the last advantage of PEM technology, the capacity to overdrive the cell stack. This means running at 125% of nominal capacity. It increases the availability of the plant, and it also allows to reduce the sizing of the plant, optimize the sizing of the plants, and so reduce the capex. I leave you with the picture of our 20 megawatt PEM electrolyzer in Canada. You're very welcome to visit it. It's in operation since more than 1 year without issues. And we're actually building the big sister in the USA, in Florida, 25 megawatt with the same product. Thank you very much.
So, thanks for the spontaneous response. Up next on stage, we'll be talking to Hadi Fadlala, who is project manager at Gen High, and welcome to the stage. Let me get you a microphone.
Thank you. Okay, so thank you for the invitation. In fact, I prepared a rapid presentation. My name is Hadi Fadlala. I'm a project manager at Jenny's company. Today I'm here to present our technology. So Jenny is a French company specialized in producing and fabricating electrolyzer system for green hydrogen production. So the French-based company owns and masters the whole hydrogen production chain, from the membrane fabrication, the AEM membrane fabrication, to the catalytic layer on the membrane, the deposition of the catalyst, to the stack assembly, and the whole balance of plants and electrolyzer unit production. So our AEM membrane, anion exchange membrane, is produced in our facilities today at Orly. Our membrane is proven to be performant. It's a ceramic-based membrane that is proven to be performant in alkaline medium. So our stacks functions in a basic medium. Our membrane is a composite membrane with an optimized ionic conductivity and a high mean time before failure. So the lifetime of our membrane is proven to be around 7 years of functioning, or 50,000 hours of operation. And as I mentioned, since we operate in alkaline medium, we don't use any rare metals for our catalytic deposit layers and either the electrodes. Our technology is proven to be highly efficient. So we have a proven efficiency of 85% on the stack in high heating value. This efficiency represents the nominal operating point of our technology. Each stack at nominal operating conditions can produce 25 kilograms of hydrogen per day at 30 bars of pressure with a 50 kilowatt capacity and a lifetime of 8 years. So as you can see here, our efficiency was proven by a third-party laboratory, the École des Mines in Paris, France. You can see the efficiency curve of our proven efficiency around 85% at 0.7 ampere per centimeter square, which represents our nominal operating point in order to have the 7 to 8 years life cycle. Of course, we can operate at different ranges of current density. And since we have our AEM membrane, we can have a compact stack of 500 centimeters square of surface density. So we are not obliged to have massive stacks in order to produce high quantity of hydrogen. And just next to the efficiency curve, you can see the polarization curve, which represents the operating point that we have chosen. So due to our AEM membrane and zero gap stack architecture, we can have a modular approach for our electrolyzer system. So as I mentioned previously, we have a compact stack of 50 kilowatt capacity. This stack can be multiplied based on demand. So we chose the modular approach of clusters, as you can see over here, with the 200 kilowatts per modulus. So each module can have 4 stacks of 50 kilowatt nominal capacity and can be multiplied based on demand. So mainly we have two kinds of products today: a 20 feet electrolyzer unit with a capacity between 100 kilowatt, 2 stacks, up to 400 kilowatt, 8 stacks, and another 40 feet electrolyzer unit with a capacity that goes from 600 kilowatts, 12 stacks, to 1 megawatt or 20 stacks. Of course, today we identified several kinds of applications and markets for our technology. As you know, there is a lot of demand today for the mobility application, refueling stations for several tens of kilograms of hydrogen per day at 350 and 70 bars of pressure, as well as another storage and power-to-gas applications and other kind of industrial applications. So thank you for your attention, and I will be delighted to answer your questions. Thanks a lot.
Thank you. You can hang on to the microphone,
Yes.
and I would like to invite all participants to join us on the stage, and let's see if we can have a conversation about what we've just heard. Do we have our... Yeah, there they are. We can crowd the stage. So it's going to be a difficult thing to find a common narrative here. There's ways of talking about these equations. One is the engineer's dream. So small scale, we'll be talking about an adapter technology tomorrow. We have the co-founder in the room here. What is interesting about that model, of course, is you can have the purity of a renewable source of energy in a remote location. You have the electrolysis on site, you store it, and then you use it in a PEM cell. Wouldn't it be lovely if the Earth were so simple? For me, it's always interesting to hear not only what the source of energy is you're using to perform electrolysis, but where the market is, what you're doing with this stuff. Is this decarbonization of the industry? And what markets are emerging that are actually increasing your prospects to expand your business? When I'm sitting over there, I'm talking to the people who are doing things like tanks, and they're saying, oh, wow, this is going to be a great year because shipping, the closer you get to the shore, you don't want the diesel the smell. There's a whole place, Sweden, the coast of Norway, where you can't really just sail onto the coast. Italy, and so they're building tanks. They're building ships that run on factually electric motors. But what is their fuel? It's hydrogen. So what I'm asking here is an unfair question because it involves commenting on the status quo now, what you do with the hydrogen you produce, what energy sources you use, and what your actual goals are. Because if it is a growth model, it's going to be a change in demand. I don't see a huge evolution in demand of hydrogen from other sectors. I may be mistaken here, but if you could start the discussion off, David, where exactly is your business model right now, and what are the prospects?
Yeah, well, first, we're a startup, so we're just getting commercially launched, but certainly we've looked at the market, and in my past experience in the market, the markets today are the industrial markets, obviously. You know, they exist today, glass, steel, the hydrogen fueling is there, electronics, et cetera. Those markets are there, and they're already looking to decarbonize. So as all of the companies here, you know, like what are some of the commonalities? All the companies are looking at different approaches for reducing the cost of renewable hydrogen. So as that cost parity comes closer and closer to fossil-generated hydrogen, you're going to start to see the current hydrogen markets start to convert, because decarbonizing is definitely the way all those markets are looking. Then as you look, perhaps, you know, near term, but even more in the future, you know, power to gas, some of the power energy transport markets, basically, that's where some of the big growth we see coming in the near future.
Jeremie, yeah.
Yeah, it's quite an interesting question because, as I said, we have a portfolio of product that fulfills all the scales of projects. And we see various customers actually coming for various scales of projects. While decarbonizing the first movers like refineries or ammonia production, that's an obvious reason. But here we need to come to scale. But the interesting fact is that those guys are also coming with small-scale projects because they realize, oh, here and there, I also have hydrogen need, and actually I can fulfill it with existing products, commercially available products today. Mm-hmm. The other part coming, the hydrogen energy, this is coming too. But actually, we need the other, the feedstock consumer to launch the race to large scale so that we can then be ready to provide the hydrogen energy sector with the large scale products that they need.
Florent?
Yeah, this one works. That's indeed, it's not a very fair question because it's difficult to answer. But actually, what I can share with you is that what we have seen in the last months and last years, there are different sectors very specific. Like the mobility one is, to our understanding, very different from the power-to-power, and the case of SIOG that we have shown is also specific, that fits with certain business model, like insular business model, but which will exist around the world. But then if we go for the large-scale ones, making it very simple, we have seen a lot of industrial players coming to see us, mostly, I would say, with a short-term view to take care and to implement the consequences of RED II, for example. And then you realize that the scale they're looking for is huge. If you take one example, you take three segments, which would be the chemical, the oil and gas, and the steel industry, and you make a very simple example. You take what should be the size producing hydrogen of a single train SMR, you take a Haldor Topsoe, whatever, and you just try to see what would be the size of an electrolyzer to completely substitute the hydrogen of only one typical train for each of those sectors. You will see very easily that for the refinery, for desulfurization, you will end up with an electrolyzer which would be typically not less than 200 megawatt, which is already huge. When you go for ammonia or methanol, you will be in a range of something between 300 and 500 megawatt. And then if you go to the DRI sector in steel industry, then you are skyrocketing this value, which means that anyway, if any of those industrial players would decide to move and to shift even a small part of its current hydrogen SMR production to electrolyzers, it already represents a very high size in terms of electrolyzer and in terms of capacity captured for the production of the electrolyzers worldwide. And what we see actually today is more and more industrial players who are trying to make some tests on what they consider to be even a small scale compared to the overall hydrogen that they are consuming in some of their plants, but which represents already quite big projects, minimum 20, 30, 50, 100, 200 megawatt. And that's clearly something, and I was mentioning the RED 2 before, sorry I'm a bit long, but we see this as a real driver for the short term. Some segments might come a bit later on when they consider hydrogen more than a commodity in their historical business.
Okay. Jeremie, how do you take that? Sorry. Hadi. Go ahead.
Yeah. So for me, we keep it simple, in fact. Jenny is a startup that started in 2019, and we will mainly let the market, in fact, guide us. So we will go with the flow if you want. So today, as you know, there is only 1 to 2% of the hydrogen produced nowadays that comes from, as we call, green hydrogen. The rest is gray hydrogen or either blue hydrogen.
Could you define those two things for the public, just so they understand gray and...
Yeah, of course. So the gray hydrogen that comes usually from fossil fuels. So there is a CO2 production behind it. And blue hydrogen is more or less like rectified gray hydrogen. So the green hydrogen, in a perfect word, it's what comes from coupling the electrolyzer with a renewable energy source without CO2 emissions. So as I mentioned today in my presentation, we are producing systems that goes from 100 kilowatt of nominal production capacity, which represents 50 kilograms of hydrogen per day, up to 1 megawatt electrolyzer unit, which represents 500 kilograms of hydrogen per day. So, of course, we identified several markets and several applications. Most of them today, the demands are coming from the mobility and refueling station applications that request such kind of, let's say, moderate or medium capacity as McPhy, I guess, mentioned today. There is a lot of demand for big electrolyzers, 100 megawatt, 200 megawatt, 300 megawatt. So for us, this will come with the demand of the market. So we are keeping up with the market, and let's see where we will arrive.
Okay, Saro, your take on this.
Yes. Okay, as a company, we get requests very frequently to compare different technologies. Since we have the free technology, we have requested to put together different systems and to compare. Because we have to remember this is a niche market, and what the implementation we are doing in new systems need to be tested. We are in these phases. We are speaking about 100 megawatts. But we are at the phase in which we have to implement, improve the technology. We are working mainly in North Europe, in the projects where we need private projects, where we need application in industrial application. In Italy, we have a problem because there are too many expectations on investment from the recovery fund, still for the COVID, and there are no investment at all. A lot of tenders, but we don't know when. So for this reason, we prefer to focus on the European market, and but we are requested to work mainly in localized production rather than the big factory. Actually, we have many tenders, many requests, but we do an exercise together with the clients, especially from Turkey. So I think we are everyone here. We have at the starting point. This is from startup or more mature company. We have to work together, I think, to help clients, customers to understand what they need. This is very important.
I find this fascinating. There is a disconnect in all of this discourse. One of them being if Robert Habeck, the Minister of Economics, was here and he's talking about replacing fossil fuels with hydrogen, he wouldn't understand this like local application focus, the focus on demand. You either follow demand or you drive demand. And to give you one example, we have companies that say we're curtailing right now renewable energy. One should be aware in Germany, if you look at the debate in Germany, they've decided recently, suddenly and finally, to get rid of these laws that prohibit people from building wind turbines close to communities. This was driven by nutcases largely in Germany, and it impeded the development of renewable energy. Where there is renewable energy, there is often curtailing. So what does ITM do in England? It says, well, we can save every kilowatt. And so what do you do with the hydrogen? Well, they've got permission to dump it into the natural gas grid. People think, oh, what a waste, what a waste. So the second thing I wanted to mention, the first thing is like to, create interest in renewable energy by utilizing as best you can what is available. The second dynamic I find very interesting is the use factor. In 1928, Nel was already using renewable energy. They had waterfalls and stuff like that, and they just couldn't use it all in the form of electricity. So they, in 1928, were already adding hydrogen to the electrical grid, to the gas grid, I should say. This is not optimal, but when we get to efficiencies, isn't it always the case when people say, my alkaline product is 85% efficient? Well, if you can recover the heat that you create in electrolyzers, the efficiency is like, to what extent is that actually getting in the way? They will set up a gas power plant to fill in the holes in the electrical grid, and it will operate maybe like 15% of the time. Is anyone complaining that the capex? That's a really bad proposition, isn't it? If you have an electrolyzer, you want it operating almost like 24/7. So what I'm getting down to is we have a very Eurocentric view on this, and it sounds crazy, but I'm talking about literally the predicament of an established energy economy whose fate is already on the wall. We're doomed. We have to do something to replace natural gas. And somehow the Eurocentricity is seen, for instance, I want to get back to French Guiana. There are areas in the world that don't have an existing grid. And it's a lot easier. It's kind of like, some people go from no phones to mobile phones. And the metaphor here is you go from no electric grid to local production and consumption. I'm not sure if that is part of the plan there, but what changes when you go to Africa?
Well, I think just to complement what you say, your point is absolutely true. I do believe that it's very difficult to have a visibility on what will happen in some areas just like this one. But at the end of the day, what you mentioned is clear. We are not free, and hopefully we're not free, from situations where at the end of the day, it will become more efficient to have some electrolyzers in remote places, to develop some kind of spot specific areas, to have such an economy which would be much more efficient, considering everything all around, than setting big infrastructure to bring power or whatever. So it could be that this would happen, yet I do believe that one of the, and that's our perspective, one of the key topics at the moment is also within Europe at least to be able to see the complete ecosystem emerging prior to maybe dropping it outside of Europe for several reasons, and also for some not only economical reasons but also political reasons, which are all about the self-sustainability of the European ecosystem, and keeping the whole industrial ownership, let's put it this way, which is very important, which makes sense, and which also resonate compared to what happened several years ago in terms of PV between China and Europe, for example. So there is also not only the economics and the industrial part of it, but also this sustainability to take into consideration.
We have two novelties, I should say. David at AquaHydrex, new, and at the same time, Cummins, who they invested in our friends here. You've acquired, if I've got this correct, Hydrogenics. So this means a Fortune 500 company has strategically moved into this field. for me, the interest is in the question, what interested you? What motivates people now? Is there anything particular about the environment? I have a very German take on this, obviously, because I'm stuck living here, but also because of the political decision makers and what they're hoping from this technology. So, David, what is your take on this? Why now?
Great question. I think you could answer it lots of ways. I'm going to take one or two angles on it. I used to work at an industrial gas company. We made lots of hydrogen. And I used to think, 10 years ago, I would think, okay, we're going to put electrolyzers in, but I can't think of a more expensive way to make hydrogen than electrolysis. This was 10 years ago. Things have changed. And what's changed? Well, the biggest cost component in hydrogen made electrolytically is electricity. So renewable power costs have come down tremendously in those 10 years. And that's the biggest cost component in the cost of hydrogen. Additionally, companies like those on the stage here and hopefully new ones have really worked the electrolyzer equation. The cost of the electrolytic equipment itself and the efficiency has improved tremendously over those 10 years. So why now? I think to me, it's that intersection of those two things. You see the lower cost renewable energy and the development of much lower cost electrolyzers. There's a lot of, even though we're different, we have different business models, different technologies, there's a lot of commonality, and that would apply to all of us, I think.
Mm-hmm.
Yeah. Completely agreed on the price of electricity. This is definitely one of the biggest driver that changed actually that shifted towards green hydrogen or electrolysis at least. But there is an additional element. I think it's the Paris Agreement, because big moves in industry, big changes are always driven by the industries, but also by political involvement. And with the Paris Agreement, actually, we got that political push since 5-6 years now, first on electrification and now on hydrogen to complete decarbonization. So, in my opinion, this political push helps big companies like Cummins also to understand or to see their interest in moving towards this technology now and not 10 years ago and not in 10 years, but at the right moment that is now.
Saro, do you have a take on why now? You're, do we have a microphone here? Yeah, you do.
Yeah.
What's so special about getting involved in the electrolysis industry right now? Is it renewables, as they suggest, and how inexpensive energy is?
But actually, in this moment, energy is not expensive at all. Mm-hmm. This moment, actually, no, because in Italy, at least, we have the megawatt increase a lot because we are dependent by the gas from Russia. It's not like France, like other countries, so we have a problem there. Mm-hmm. But still, these make paradoxically economic the production, competitive the production of hydrogen with the green energy compared to the gas. Mm-hmm. So this is something that's happening now. But the possibility to spread the application of electrolysis systems in the market, in the different applications, will help the reduction of the cost. This is very important because otherwise, 20 years ago, like you say, China, we have the megawatt, the watt of a solar panel was about €3 per watt. Now we have 30 cents because there is a wide application production in China. What we need to avoid this now, to produce as much as possible in Europe, don't export technology because otherwise we kill ourselves. We need to export equipment, not technology. So we can be competitive, we can be always ahead, and then we can reduce also the cost. Because now, if this machine will be produced in series, like we want to do, we can cut the cost about 30%. So this is the game we have to do. We need to insist to support this industry to create incentive. Without incentive now, it will be very difficult to be competitive. Especially, I speak about Italy. Italy, we have some problem now because without incentive, the market stops. So everybody's waiting for incentive. So for this reason, we need to watch other markets where the renewable energy is something not normal. So we don't have a power station, nuclear power station. We don't have enough gasification plants. So we have really a problem now. Yeah.
And Hadi, what is your take on where things are going now?
Yeah, in fact, it's a mixture of all what my colleagues have said. In fact, for me, as you mentioned in the presentation, that a few years ago, only few percent of electrolyzer suppliers were present in the exhibition. Today, we occupy most of the region of the exhibition. So as you can see that it's a mixture of several factors. For me, there is a lot of changes that happened recently. Of course, a lot of political forms, a lot of decisions that have been taken to switch towards more renewable sources of energy. That helped a lot also to reduce the cost. And at the same time, there is a lot of pivot changes that happened in the last few years. I guess the COVID, the war, all of this have shown how much our economy is fragile and dependent on fossil fuels. So this have really opened our eyes to depend on other sources of energy, to multiply the resources of energy. And that's where hydrogen comes in, to say, okay, there is an alternative, so let's look forward for it. And as much as there is a lot of companies that are working on developing hydrogen production systems, the cost will go much lower and lower. Of course, this should be accompanied by a lot of political decisions that should endorse these kind of applications and systems, and of course, hydrogen industry.
When we talk about this whole theme, and then I look at the manufacturers of, for instance, PEM cells that we discuss over there, it's always unusual for me that it's not simply about greenhouse gases as we classically interpret them. There's European legislation that limits the amount of pollutants diesel cars can produce within cities, where they accumulate often. And this is very interesting because already I can sue the Berlin mayor if the levels are above a certain peak of tolerance, which actually puts pressure on them to make sure that they have to stop the traffic, right? This is like horrific for logistics. The spin-off of that is, well, they simply have to work towards hydrogen-fueled buses, delivery vehicles that don't use diesel, either electrify them or, and often is the case, it's a combination of battery and fuel cells. That is, this demand is there. And that hasn't even been mandated by the fatality of this war or the notion of CO2 emissions, primarily. It's a pollutant, right? I often, that's just an example for me, I often wonder whether on this larger issue of replacing fossil fuels, we simply distrust the narrative until the business model is there. How often have we seen that we're going to move forward with renewable energy, and in fact what has happened, at least in Germany, is they've blocked it. Now all of a sudden there's this impotence. But I asked, like, what they've been asking from the electrolyzer industry is to provide larger scale of hydrogen before actually making clear what the business model is. That is, they have been assuming that someday we're all going to have a green environmental energy economy, but they haven't really clarified through legislation where it will become necessary. There are a few cities. We know that, you know, I think both Paris and London have restrictions. They like hybrid cars. Taxis have to be a certain type. There's all sorts of things happening there. But last question from me, and then we'll open this to the audience. The question is, do you find the business prospects of the electrolysis industry driven right now also by political mandate and initiative? Yeah, who you want to take that question?
Well, I can start.
Yeah.
I think we all agree that most of the answers have been published some days ago with the delegated act of the RED II. So here we can see clearly the implication for the hydrogen business, for the electrolysis business. I mean, it's pushing even more than it was before. So it's a very good sign. It can be better, but it's already very well what has been achieved here. So yes, there is a political move. It comes in Europe from the European Union and will be translated in all the countries. But we see it also in the US. We're an American company, and we see that the Biden administration is also putting in place legislation that will help to move towards electrification, hydrogen, and zero-emission mobility. And the industry, let's say, anticipates and follows. Cummins anticipated somehow and follows also now that legislation is coming. the political push can only come by listening also to the industry and the reality of what it is facing. So if the industry says we can do it, then political push can come. But if the industry is reluctant, we need also the political movement to understand what is the problem and how we can solve it. And I think we're doing it right in Europe. I think they're doing it right in the US. And the rest of the world is also on a good path towards those political pushes.
Yeah, very well said. It'd be hard to add more to that. I agree. It's both a push and a pull, to answer your question, and which is it? It really is both. You see positive signs with policy in Europe, starting to see some of it in the U.S. with the Biden administration. We'll see where that goes, and we have high hopes. But I think I'd add also, it's not just the incentive aspect on manufacturing and on decarbonization, but it's also a policy. Working as a community with the policymakers around making it easier to site and permit, electrolyzer systems or hydrogen fueling stations or, renewable energy is going to be a part of this as well. So it's not just working with the policymakers around those incentives, but it's also on the actual policy and permitting as well.
If I may just add to what was, I fully agree with what you have said for sure, but it's clear indeed that the political authorities are, as I feel, deeply in their right position. They are a quick starter and they're a booster of this complete ecosystem and economy. That's why, namely in Europe, they are helping the project, but they are helping also structuring the complete ecosystem with the IPSI, structuring the complete capacity for producing the electrolyzers. But it was said, otherwise if I'm mistaken, but it was said from the very beginning, the aim is not that this ecosystem will be subsidized forever. The idea is really to kickstart and to boost the first initial step of the development of the complete ecosystem, structuring everything. Once the scale effect will appear, the idea is that sooner or later, and the sooner the best, this economy can become self-flying and can completely enter in the KPIs of the economy and of the whole industrial players.
For me, of course, we should be accompanied with political support in order to boost this industry. As we all know today, for example, we have the Ministry of Economy present, representative of the United Nations. All of this shows that there is a lot of political interest that is going around the hydrogen industry. So for me, of course, this should be translated by decisions. And one of the decisions that happened recently is that we saw that France and Germany have invested a lot of money, billions of euros in hydrogen industry. So it's, as he mentioned, it's the kickoff. So it started and it should be accompanied with more political support. And of course, if it goes on and on, we could achieve much better results.
But unfortunately, a little bit negative for what concerns Italy. Because I'm very honest about this, because I'm very happy about what you say about your countries. The problem is that in Italy we have a situation where the government is a mix of strange animals that they don't speak each other, they fight each other, and they speak everywhere. Everywhere we can speak about hydrogen. We need to change the situation, green energy, but we have a gigawatt of project or renewable energy blocked because they don't give a license. We have for a wind farm, we need 14 years to be authorized. A solar farm, we need between 3 to 4 years. And now we have, they try to push, they liberalize some procedure, the region, they are blocking, because they don't want to lose the role. So this is, another thing is they discuss about hydrogen with any kind of minister, but they forgot the Minister of Internal Affairs, where depend by the firemen, the fire forces. And without them, we cannot have authorization to set up a new refueling station. In Italy, we have only one refueling station for hydrogen in Bolzano, only because there is a special law not following the national law. So in Germany, we have one new station every week, more or less, starting. So I hope if some politician in Italy listen to me, that we need really to speed up Otherwise, company like us, sooner or later, will go away because we cannot wait the politicians agree with themselves what to do with our future. So this is, I'm very negative in this because very honest that we need really to be fast and concrete because the political games we have in Italy normally is not, this is the moment. Okay.
And there is a danger of letting the European Union legislation try and do all the work for us.
Yes.
To give you one example, so in Norway, sadly not represented right now, if you want to fill up your electric car, it's free. And there's areas where you cannot drive unless it's an electric or hybrid vehicle.
Yeah.
Now, why is that the case? It's the case because you guys know the answer already, right? There's a lot of renewable energy there. So my bottom line to this is, we're juggling things, but if you really want to drive any transition, whatever, you have to go overboard with developing renewable energy. You have to have such an excess that using it is super affordable. Mandating it makes sense. The optimization of renewable energy, which is there's oodles of it at the North Sea. And once that happens, things will slowly start to change. My skepticism is whether it's going to be possible to transition step by step, incrementally, without having a vast expansion of renewable energy. As long as we're talking, of course, about green hydrogen, because electrolysis does everything. Let's open this up to the audience here if there's any questions. Does anyone have any queries about the development of the electrolysis industry? Everyone's being shy. Is there someone from the hostess department here that is doing the serving of water and stuff like this? We were supposed to get drinks for like 4:30. Are they there, the beverages? Beer and wine? Go get it, because if you could scare them up. They're supposed to be delivering at 4:30, and we're getting thirsty up here, and the audience as well.
Italian wine.
Yeah, tell them we need, pronto. They're being slow. So that cynical remark, it is a bit cynical, isn't it, to say that largely there's going to be a policy change and people will start building wind turbines. The wind turbines will be contractually so devised that you have to pay for the kilowatts being produced. The farmers will be interested in them, so they'll grow like mushrooms, as the Germans say. Die schießen wie Pilze aus dem Boden. Yeah, they'll be all over the place. That could be a driver. But let's not underestimate the markets as they are right now. And just briefly, so we have a sense of realism here, what the politicians who visit us today are expecting is that we replace fossil fuels and that hydrogen is going to be a huge contributor to this. I don't even know whether it's possible to scale up to that extent. This is a materials question as well. We're going to run out of stuff for batteries if every car is an electrical car. Some people say we're going to run out of copper if we have to really build electrical fueling stations. Is it even possible to scale up that much? Is this a politician's dream, or is that even an option as we go towards a green economy? Let's start with the Fortune 5 take on this, because you've just moved into the industry. How large is the growth prospect?
It's ambitious, for sure, but it's realistic. And here I would like to say it's a team effort. We need Cummins, we need McPhy, we need AquaHydrex, we need all the companies that are present here on all the booths, because the demand will be extremely high. Again, on the delegated act, you see that there is a further push for electrolysis demand. We will not achieve it alone as a company. There will be no hegemony of one company in the next years. It's realistic because we can do it also globally. And the European Union, or Hydrogen Europe, has been also clear on the objectives. A big part of hydrogen will be produced in Europe, but a big part will also be imported. And that's why it's important that European players scale up in Europe, but that we also scale up all over the world. We're building new capacity, for example, in China to serve other markets. We're building up capacity in North America. That's also a question of what are you capable to deliver to the market where you are selling? The regulations are different. You need to provide a product that is compliant with the regulation of the country. And you will have champions of some countries. I'm pretty sure McPhy is the champion of France for delivering on French regulation. But you will need to have diversity also, so that other different companies can compete on different geographies. And I think we will achieve it as a whole industry.
Are you the champion of your native country, or do they listen to techies there?
But in this moment, I think we are the only one player that is able to, at least in Italy, this is our feeling, okay, as Italian, because then we have a McPhy, we have competitors from abroad that can do this, but to produce PEM at a large scale. What concerning the large scale, I'm still doubt about the, I repeat, for the distribution and storage. This is a need in a lot of investment in this sector, because the storage is cost more than the electrolysis system, if you will see, depending by how long you want to store. So for this, we need to go local. We need to push at the beginning to help, to support a company like us to develop the market as much as possible until we see the positive scenario in the storage. Because when we speak about 1,000 kilo, 350 bar, we speak about 1 million euro. No, this means 14 hours for 1 megawatt storage, 1 million euro storage. It is impossible to think about a large scale in this moment. So we need to produce where we need the hydrogen. Now we call even 0 meter. When we produce hydrogen near to the boiler of 20 megawatt boilers, this is feasible. But to 20 megawatt hydrogen to ship at 50 kilometers is quite complicated. So for this, we need to wait a little bit.
David? Yeah.
Yeah, I'll just add a comment to what was said already. You were thinking, taking the skeptic's view. What about, can you really ramp up the manufacturing? What about supply chain? Are there things in the supply chain that are just going to stop this? And I'm actually encouraged quite a bit. Like, you look at the diversity of technology and approach just here on this stage, and it's broader than just right here. But you think about that, people are, as an industry, are committed to ramping for the manufacturing, designing for scale right now. So the scale, we can do it as a group. We will do it, and that ocean, rising ocean, will float all the boats. I mean, there's room for everybody. That's one thing. On the supply chain side, the diversity on supply chain is actually a great thing, right? Because if it's tight on one catalyst material or membrane or something, there's somebody else that has a slightly different technology. So that diversity actually eases pressure. It's not everybody going after one molecule or one membrane or something like that, which is actually a positive.
This was actually also a question of material science. Yep. Is it possible, physically possible? But your take on this, Bertrand.
Indeed, your question is a very, very, very wise question. It's a true one. It's clear that the targets which have been set are very challenging. We do believe that those targets can be achieved. And as you said, they will require the assistance and the efforts of the whole ecosystem. That's very clear. What we know also, which is really challenging, if you look at the real project, I mean the one which are in production or which have been produced. We are talking a lot about 100 megawatts electrolyzer, a few gigawatt electrolyzer, but the real project which are in production, which have been delivered, there is your project, we have our CO project which is under production at the moment. There is not so many, in fact. Why? Because we see that it takes time. When you go from, and we're going through this path, when you go from a lab test and small scale to higher scale, industrial scale, the reality is that it takes time. The devil is in details. So you need to debug the system, and it takes usually much longer than what you are expecting at the beginning. And that's absolutely normal. And we will have to go through it, and the quicker all the companies get aligned to be able to tackle these challenges, and the best it is to be able to reach the target. The target is realistic. Typically and clearly, it will be very challenging.
Yeah. And your take on this?
Yeah, for me, I agree completely with what David just said. For me, the scale-up can arrive. There is a lot of diversity in the market today. There is a lot of suppliers that can supply a few kilowatt electrolyzers, a few hundreds of kilowatt of electrolyzers, and a few hundred of megawatts of electrolyzers. So there is a room for everybody. And the market is big. However, for me, we should go step by step. Today, it's the demand who will guide us. So I don't think it's a wise idea to start just producing hundreds of megawatts and gigawatts of electrolyzers, and at the same time there is no demand. So let's wait the market to evolve, and we will evolve with the market. And of course, regarding the supply chain, there is a diversity of suppliers for all the materials of the electrolyzers, from the balance of plants to the membranes, to the seals, to the plastics, gaskets, everything. So the market is over there, and the suppliers are over there, and the fabricators of electrolyzers are developing their technologies. Just let's wait the market to evolve, and we will go big with the market.
No, a short note. We need also to remember that the cost increase we got in the last period. That machine, compared to the 2001 January and now, we have increasing cost of material 40% between copper or components and so on. There is a very big challenge for us because in the mind of the clients, that we have an average price that is maybe 2-3 years ago on the books. But the real price, when you build a machine, you realize that you cannot meet the expectation for the clients. I don't know if it's the same experience for you, but we have this problem. So this is another issue to be addressed, that if we need to be competitive, but we need also to be helped about the problem of the material. That container was built by us, it's not a standard, cost more than double compared to 1 year ago. So this is the frame, for example, the steel. So now the steel price increased double. Also difficult to get the delivery on time. We have some PLC, we need 1 year to receive. So this is another issue that we need to remember, is a challenge for our market.
You had the perfect interpretation. You cannot expect from the electrolysis industry to just go and build volume, right? Just do it at your own cost. And that's why I tried to reformulate the question of what happens if you supply in excess of renewable energy and say what's the best case use. Cases like Norway give me hope that we're going to get to a green economy more quickly. That's back in 1962. This is sort of my closing remark. By the way, any questions now, because we're approaching the end? If there is a question, we have time for one. In 1972, the Scientific American produced an article that got me startled as a child. It was called The Hydrogen Economy, and it was this beautiful scenario of you have renewable energies through the sun, and you create hydrogen, and when you need electrical energy back, you run it through a PEM cell, and it's pure. And this purity concept fascinates a child, also an engineer, who has his heart in the right place. But the conversations we've had here, just to go back in time, are fascinating for me. Sometimes it's grid stabilization, sometimes it's focusing on remote locations. Now there's industrial applications where I had always thought if it's industrial, they're going to do reforming of natural gas. Then we had this term fossil fuel parity. And this is going back to 2017, where we had a kilowatt hour of hydrogen that was competitively priced with electricity in Germany, a phenomenal achievement. Things are changing quickly, and I often wonder whether my take on this is a falsification of the situation from the manufacturer's side of electrolyzers, because you really have to have the business model now. You have to have contractual basis. You move forward because there's an order on the books. But it is this dysfunctional thing one sees on the news. What is expected from this industry is literally to harvest all the renewable energy available, and if it's not used instantaneously in electricity, it's going to be converted into hydrogen. So with that note, these are the people you should be investing in, because there is a future in this industry. I hope we see you all back here next year for another round of our conversations. They're very informative, and I'm grateful to all of you. Thank you.
Thank you.
Thank you.